Okay, welcome to my classes. Dear students, I hope you are watching the classes effectively and making the notes. If you have any doubts, please don't hesitate to ask the questions and clear your doubts. We can continue our discussion. Last couple of classes, I have been discussing about Van der Waals equation of gas, how real gas deviates from ideal gases, and the variation of pressure with the real gases, the deviation with the pressure with the real gases has been discussed, and now we are going to effect of temperature, how temperature affects the deviation of real gases from ideal behavior. At a high temperature, at high temperature, volume is volume is very high. When volume is very high, likely very low pressure condition. Therefore, high temperature and very low pressure conditions are matching each other. They are liking each other because at a high temperature, volume is very high. Therefore, our equation P plus A by B square, V minus B is equal to RT. In this equation, these additional terms, this term with the co-volume or molecular size, and this term with intermolecular forces of attraction can be neglected. This can be neglected. What is the mathematics? Volume is very high. Therefore, V square is again high. A and B are comparatively smaller. Therefore, A divided by V square term. Similarly, B term. This is very small and can be neglected when V is very high. What is V? This is the volume of the container. Therefore, volume of the gas, that is this V, become very high. The terms A by V square and B can be neglected. Fine. Therefore, the resulting equation is PV is equal to RT. That's ideal gas equation. This is a summary. Hence, real gas behaves ideally at high temperature. And I add one more conclusion. After all the discussion, the sum up, this is our sum up. Every real gas can follow ideal gas equation at very low pressure and very high temperature. Okay, because in both cases volume of gas is very high. Therefore, the terms A by V square and B are neglected from Van der Waals equation, Van der Waals equation. Fine. Therefore, Van der Waals equation will be converted into ideal gas equation. Now I go to something deep. Suppose you take Z versus P graph of N2 in different temperature. This is the graph of Z versus P of N2 gas, nitrogen gas, at different temperatures. What are the temperature? 20 degree, this is the graph. Minus 50, this is the graph. Minus 70, this is the graph. 50 degree, this is the graph. And obviously, this is the graph if it behaves ideally. This is ideal graph, ideal plot of N2. What are the features of the graph? First, when temperature increases, the dip of graph plot also increases. Okay, this is a dip. Okay, maximum dip at minus 70 degrees centigrade. Therefore, more the lower temperature, more the tendency towards negative deviation. Okay, how do you justify that? Because lower temperature, it will go to the liquids. Therefore, in another sense, when temperature increases, the dip increases. At a particular temperature, there is no more dip and the plot is almost horizontal to ideal graph of the ideal gas, almost horizontal. Okay, that temperature is called boil temperature. This is TB, boil temperature. A graph is almost horizontal to ideal plot means at that temperature gas obeys ideal gas equation. And that temperature is called the boil temperature. What is a boil temperature? Boil temperature. What is that? Very important point. What is the boil temperature? It is the temperature at which a real gas obeys Boyle's law or ideal equation over a range of pressure, over appreciable range of pressure, a good length of the pressure, a good range of pressure, that real gas obeys Boyle's law or ideal gas equation. That temperature is called boil temperature. Therefore, in short, at boil temperature, real gas almost behaves as ideal gas. Therefore, we have a limit. In that limit, suppose this is the boil temperature of the gas. And what is a graph? What is the temperature at which this plot is drawn? Obviously, because it has a negative dip, therefore this plots is at a temperature below the boil temperature. These are the plots of real gas nitrogen or nitrogen gas below the boil temperature. And suppose you have a graph here, it's another temperature for nitrogen. Obviously, that temperature should be greater than boil temperature. Therefore, if this is the plot for boil temperature, this is the plot for a temperature below the boil temperature, and this is the plot for a temperature above the boil temperature. It is above, greater than boil temperature. It is below or lower than the boil temperature. And this is the plot for boil temperature because it is almost horizontal to the ideal plot, and this graph follows ideal gas equation in an appreciable level of or range of pressure. Okay, please watch this. If any doubts, please ask me, clear it. make the knot perfectly. And please subscribe the channel, share to your friends, and have a nice day. Thank you.